After years of working to close the gap in aircraft carrier technology, China now appears to be entering a new chapter in the modernization of its navy. The emergence of a new image showing a J-15T carrier-based fighter taking off from the aircraft carrier Fujian while carrying 4 YJ-83K anti-ship missiles has become a powerful symbol of that progress. At first glance, it may seem like nothing more than another military exercise. However, defense analysts believe the image represents a much more significant milestone in China's growing naval capabilities. For more than a decade, China has steadily expanded its aircraft carrier program. Its first carrier, the Liaoning, was rebuilt from a former Soviet vessel and primarily served as a training platform to develop carrier operations and pilot experience. That knowledge later paved the way for the construction of the Shandong, China's first domestically built aircraft carrier. Although both ships represented major achievements, they still relied on the traditional ski-jump launch system, which imposed important operational limitations. With a ski-jump launch system, aircraft must use an upward curved ramp at the end of the flight deck to generate additional lift during takeoff. While this design is mechanically simpler than a catapult launch system, it restricts the maximum weight of the aircraft. As a result, fighter jets often have to reduce either their fuel load or their weapons before taking off safely. Those limitations directly affect combat performance. Carrying less fuel reduces operational range and time on station, while carrying fewer weapons limits striking power during combat missions. In modern naval warfare, where aircraft are expected to conduct long-range missions while carrying a full combat payload, these restrictions can significantly reduce the effectiveness of an aircraft carrier's air wing. That situation is now beginning to change with the arrival of China's newest aircraft carrier, Fujian. Unlike its predecessors, Fujian is equipped with the Electromagnetic Aircraft Launch System, or EMALS. Instead of relying on steam or a ski-jump ramp, EMALS uses electromagnetic energy to accelerate aircraft to takeoff speed. The system delivers a smoother, more controlled launch while allowing aircraft to depart with significantly greater weight. This is precisely why the recent image of the J-15T has attracted so much international attention. For the first time, observers have seen a Chinese carrier-based fighter taking off while carrying 4 YJ-83K anti-ship missiles simultaneously. Such a configuration strongly suggests that the aircraft is no longer forced to sacrifice either fuel or weapons in order to operate from the carrier deck. In other words, the J-15T is now approaching its full combat potential. The 4 YJ-83K missiles alone weigh nearly 3 tons. Combined with a substantially larger fuel load, the aircraft can fly farther, remain on patrol longer, and engage targets more effectively. This greatly enhances the operational flexibility of China's carrier air wing, enabling it to perform long-range strike missions while maintaining a higher level of combat readiness. The YJ-83K itself is regarded as one of China's primary anti-ship weapons. Designed to destroy a wide range of surface combatants, the missile flies at extremely low altitude above the sea in a sea-skimming flight profile, making it more difficult for enemy radar systems to detect until the final stages of its approach. During the terminal phase, the missile can perform evasive maneuvers before striking its target, increasing the challenge for modern naval air defense systems. If multiple J-15Ts are launched in a coordinated strike package, the results could be formidable. A squadron of 8 to 12 fighters, each armed with 4 anti-ship missiles, could launch dozens of missiles within minutes. Such a saturation attack is one of the most difficult scenarios for any naval task force to defend against, as warships must detect, track, and intercept numerous incoming threats simultaneously. The benefits of EMALS extend well beyond fighter aircraft. The electromagnetic launch system also allows the carrier to operate heavier support aircraft that were previously impractical with a ski-jump design. These include airborne early warning aircraft, electronic warfare platforms, and carrier-based transport aircraft, all of which are essential components of a modern carrier strike group. Airborne early warning aircraft dramatically expand the fleet's radar coverage, providing earlier detection of incoming threats and improving battlefield awareness. Electronic warfare aircraft can jam enemy radar and communications, helping friendly aircraft penetrate defended airspace. Transport aircraft improve logistics and sustain operations far from home waters. Together, these capabilities transform an aircraft carrier from a simple launch platform into a fully integrated command and control center, capable of projecting air power across vast distances. China is also expanding the J-15 family beyond the standard fighter version. One of the most notable variants is the J-15DT, which is designed specifically for electronic warfare missions. It is expected to carry advanced electronic attack systems capable of disrupting enemy radar networks, communications, and air defense systems while supporting strike aircraft during combat operations. In addition, reports indicate that China is developing a twin-seat version of the J-15, intended for both advanced pilot training and complex multi-role combat missions requiring a dedicated weapons systems officer. These developments reflect China's broader effort to build a complete carrier aviation ecosystem rather than relying on a single fighter platform. Every major naval power operating aircraft carriers depends on a combination of fighters, surveillance aircraft, electronic warfare platforms, and logistical support aircraft working together as an integrated force. China now appears to be moving steadily toward that same objective. The rapid modernization of the People's Liberation Army Navy has been one of the defining military trends of the past decade. Alongside new aircraft carriers, China has commissioned advanced destroyers, frigates, amphibious assault ships, nuclear and conventional submarines, and increasingly sophisticated long-range missile systems. Together, these assets are designed to operate as a coordinated naval force capable of projecting military power far beyond China's coastline. Even so, many defense experts caution that advanced technology alone does not guarantee operational superiority. Carrier aviation requires years of intensive pilot training, highly experienced flight deck crews, complex logistical support, and continuous large-scale exercises to achieve true combat effectiveness. As a result, Fujian is expected to undergo extensive testing and operational evaluations before reaching full combat readiness. Nevertheless, the latest image of the J-15T carrying a full anti-ship missile load represents far more than a successful test flight. It signals that China's carrier aviation program is rapidly evolving from a developmental capability into a far more mature and capable force. Supported by EMALS technology and an expanding family of carrier-based aircraft, Fujian has the potential to become the centerpiece of China's future blue water navy. As China continues to modernize its naval forces, developments like these will be closely monitored around the world. Every improvement in carrier capability has the potential to influence the military balance across the Indo-Pacific, making the future operations of Fujian one of the most closely watched aspects of global naval competition in the years ahead.